Alright, lesson 2 is over climate cycles. Our vocab: Ice Age is a cold period lasting hundreds to millions of years, during which glaciers cover much of the Earth. An interglacial period is a warm period that occurs during an ice age. El Nino and Southern Oscillation is a combined ocean and atmospheric cycle that results in weakened trade winds across the Pacific Ocean. Monsoon is wind circulation pattern that changes direction of season. And drought is a period of below average precipitation. Long-term cycles. Climate changes between warm and cold periodically and gradually over time. We can learn about past climates through ice cores, fossilized pollen, ocean sediments, tree growth rings, and fossils. Ice cores, we can analyze what elements are found in the ice cores, and that tells us a lot about the atmosphere and thus the climate. Ocean sediments, same thing, we can analyze what's in those ocean sediments to tell us about climate. Tree growth rings can tell us whether or not we got a lot of rain in a certain year, depending on how much a tree grew in that year. And fossils can tell us what kind of animals or plants were living during a specific time, and that can tell us a lot about the climate. Here are the ice cores. These are drilled into the ice sheets, and they go very, very deep, and then, like I said, they analyze the elements found in those ice cores. Ice ages and interglacials. When Earth cools, ice caps and glaciers move towards the equator. That's called an ice age. As Earth warms, ice caps and glaciers retreat back towards the poles. That's called an interglacial period. So these two things just play off each other. Interglacial means between glaciers. So that's a period that happens between when the glaciers are rising or moving south. Major ice ages and warm periods. 2 million years ago, MYA, million years ago, half of the northern hemisphere was covered in ice. This is when the sheets were at their maximum. The Earth then entered the Holocene epoch, about 10,000 years ago. This is the epoch we are currently in. Even though we aren't technically in an ice age right now, temps can vary. We had the Little Ice Age, is what scientists call it, that occurred from 1250 to 1850 AD. Here you can see how much the ice sheets have spread, going deep into the United States, and this would be the current ice sheets, how much less ice there is there. Causes of long-term climate cycles. The amount of solar energy determines a lot about the climate. If you're getting more solar energy, you're going to have a warmer climate. Less solar energy, you're going to have a cooler climate. Earth has an elliptical orbit that varies almost, the cycle is about 100,000 years. The Earth has a tilt in its axis that cycles every 41,000 years. A decrease in tilt results in more moderate temperatures. And I'll show you those two things in just a second. The movement of the continents via tectonic plates can have a large effect on climate, and so can the ocean circulation. So, our elliptical orbit, an ellipse, is almost like an oval. It's like you took a circle and you just squished it a little bit. So, that being elliptical affects our climate because here you can tell we're a little bit closer to the sun than we are right here. Right? So if we're closer, we're going to receive more energy. More energy means warmer weather. The tilt of the Earth, we are on an axis of 23.5 degrees. If we're tilted towards the Earth, it's going to be warmer. Away from the Earth, towards the sun is going to be warmer. Away from the sun will be cooler. And we'll talk about that more when we start to talk about seasons. Alright, so seasons. Temp changes, number of hours of sunlight, and the tilt of the Earth's axis. Whichever hemisphere is tilted towards the sun will experience summer, and away from the sun will experience winter. Solstices. One Earth revolution is 365 days, right? 1 year is 365 days. That's what we're talking about in this case. Summer solstice is June 21st or 22nd in the northern hemisphere and marks the beginning of summer. The 21st or 22nd just depends on the year. Winter solstice is December 21st or 2nd, and that marks the beginning of winter. Equinoxes, equa meaning equal in this case. Days that the Earth is neither tilted toward or away from the sun. The day and the night hours are almost equal. That's where equinox and equal come in. Everywhere on Earth, The day and the night are almost equal. It should be about 12 hours a day, 12 hours a night. The beginning of spring is March 21st to 22nd. The beginning of the beginning of fall is September 21st to 22nd. So, we're going to look at summer and winter solstices first here. And this is speaking in terms of the northern hemisphere. So here you can see, barely, but you can see it. During the summer solstice, the northern hemisphere is tilted towards the sun. So if it's tilted towards the sun, it's going to receive more direct sunlight, thus more energy, and thus warmer temperatures. While that's happening, the southern hemisphere is getting less sunlight, so it's getting cooler temperatures. Over here we have the winter solstice, which is just the flip. Now the southern hemisphere is tilted towards the sun, so they're getting more energy and warmer weather, and we are tilted away from the sun, so we're getting less energy and cooler weather. The equinoxes, vernal and autumnal, this would be fall equinox and spring equinox. These are both going to have the same amount of daylight. We're not really tilted towards anything. Alright, so El Nino and Southern Oscillation. These are short-term cycles. What we're going to describe first is what normally happens, and then in the next slide we'll talk about what's happening during an El Nino event. So in normal situations, there's a connection between the atmosphere and the ocean. At the equator, trade winds blow east to west. Wind pushes warm surface water away from South America's coasts. As warm water moves away, cold water comes up from the deep. Comes up from the deep parts of the ocean. That's called upwelling, when we have cold water coming up from the deeper parts of the ocean. Air cools due to the cold water. The air sinks, creating high pressure. The air above that cold water sinks, creating high pressure. On the other side of the Pacific, warm air rises, creating low pressure. The difference in these pressures keep the trade winds going. So during an El Nino or Southern Oscillation event, when the trade winds weaken, warm water is no longer pushed away from South America. No more upwelling. This causes the cold, dry coast of South America to receive large amounts of rainfall. Drought occurs where it's normally wet, and it can lead to violent storms in the southern United States. This occurs about every 3 to 8 years, depending. So here we have what normally happens. This is a normal event. We have those strong trade winds blowing across, and when those strong trade winds blow across, they essentially pull that air from the coast of South America. When they pull that air, we have that upwelling happens, which means, again, we have cold water coming from the deeper parts of the ocean here and moving across. This is what happens when we have a southern oscillation or El Nino event. The trade winds weaken, and because the trade winds weaken, we don't have that pull of water or of cold air from South America. So when we don't have that pull of water, we don't have the upwelling. That results in a lot of storms right here, and it can result in storms right here for us. Monsoons. A summer monsoon is when warm air above land rises, causing low pressure. Cool air sinks over water, causing high pressure. Wind blows from water to land. This is almost like a sea breeze. Winter monsoons is the opposite. So a winter monsoon looks a lot like a land breeze. The largest to date is 10 meters of rain in Cherrapunji, India. So here's what we're talking about. We have this circle going, and again, this looks a lot like sea breeze, and it kind of has the same effect. What happens is that during these summer monsoons, this wind comes down and picks up a lot of moisture over the water, and as it moves towards the land is hot, so when it gets hot, the air rises. When it rises, it condenses, and then we drop a lot of rain. So here we have the opposite. This is a winter monsoon, where we're going from the land, which is cold. That's why we're falling here, out to sea. Here it scoops up some of that moisture. When it gets over the warmer ocean, it rises. When it rises, it condenses and drops to the water. Alright, drought is due to a warm air mass sitting in one spot for weeks or months with little precipitation and high temperatures. Cold waves are cold continental polar air masses sitting in one spot for weeks or months due to climatic changes on Earth or extreme weather. I don't think there's really a whole lot to explain with those two. I think we can put together what those are. That will do it for Lesson 2 notes.